Hello and welcome to Algebra 1 with Snowflake Learning. Today's video will cover expressions, equations, functions, and giving an overview of each, as well as understanding domain and range, the vertical line test, and there will be a linked PDF version of the notes and a Quizlet of definitions if needed. So first, what is an expression? An expression is a sentence of sorts with at least two terms and a math operator. Terms are numbers or numbers multiplied by a variable, such as 2, 1/2, 5x, 0.3z. Variables are the letters used to indicate an unknown amount. Now, what is an operator? Operators, as you might have seen before, are symbols that indicate addition, subtraction, multiplication, division, and so on. Now take a look at these four here. Which of these is not an expression? The answer would be C, because it does not have a math operator. An expression requires two components, the terms and the operator. Without any of these, it is not an expression. Under the umbrella of expressions, there are algebraic expressions, which contain variables, and arithmetic expressions that do not have variables. Now, what is an equation? Equations are similar to expressions, but a key difference, and this is very important, is that an equation sets an expression or a term equal to another expression or a term using the equal sign. In this example here, 2x minus 3 equals 5. One side is the expression, which is 2x minus 3, and the other side, 5, is the term. And what makes this an equation is the equal sign that sets them together. Now, each side can have both expressions or terms. As long as it has an equal sign, then it is considered an equation. Here are more examples of equations. They can have variables in them, but as long as they have the equal sign, then it is an equation. Lastly, what is a function? A function is a relation between a set of inputs having one output each. All functions have a domain and a range. The domain, also the inputs, are usually indicated as x values, while the range, the outputs, are indicated as y values. Due to this, a function is usually denoted as f of x, where x is the input and f of x is the output. F of x and y are basically the same thing, indicating a function, and f of x is more specific in showing how x values are being changed to become y values. Another way to describe this is using the function machine, where you can see these x values here are entering into the function machine, being manipulated and coming out as y values. Here are more examples of functions, and they can show how the function machine works, such as problem B. You have an x value here, and how is it being manipulated? Well, it's being multiplied by 6 and then added 9 to, and that makes y. Another way to show the relationship between x and y values is through here. Now remember how each set of inputs has only one set of outputs? That can be visualized using this graph in the corner. Here is a list of x values, the domain, and as you can see, each x value points towards only one y value. Two x values may point to the same y value, but one x value will never go towards two y values if it is a function. And from the y side, many x values may be going towards a y value, such as 14, but 14 and any other y value do not share an x value. That is key in knowing the vertical line test, which is a way to determine visually whether or not a graph is a function by adding a vertical line through the graph. In a function, since each x value has only one y value, it means that if you add a vertical line through a function's graph, it should only pass through the graph once at any given point. And if the vertical line crosses a graph more than once at any time, that graph is not a function. As shown here with a and b, and we are going to determine whether or not they're functions with the vertical line test. Now, in example A, here is a line. It passes the graph only once at any given time, which means that example A is a function. It passes the vertical line test. Now, example B. If we use the same vertical line and run it through the graph, you can see that it actually passes through the graph more than once, in multiple places, which means that it is not a function. It has failed the vertical line test. So in summary, an expression needs two components, two terms, and a math operator in order to count as an expression. Equations are determined through an equal sign that sets an expression or term against another expression or term. And a function is a relation between x values, inputs, and the y values, which can be denoted through this function machine, which shows how x values are manipulated into becoming y values. And the vertical line test is a way to determine visually whether a graph is a function based on how many times a vertical line passes through the graph at any given time. Thank you.